Hello everyone, welcome back to Embedded System course. So in previous lecture we finished with chapter number 1, that is programming 8051 in C. So basics of C programming of 8051 microcontroller we studied. Okay, now we are moving to next chapter, that is chapter number 2, that is 8051 timers and serial port programming in C. Okay, so we are going to study programming of two peripherals in a C in this chapter. First peripheral is timers and second peripheral is serial port. So these are contents of this chapter number 2. So after studying this chapter, uh, so you can what course outcome, okay, you can achieve, that is written here, that is EIF402 and course outcome number 2. So you can develop the critical timing related and real-time event counter applications after studying this chapter. Okay, so let us see what is we are going to study under this chapter. So as I told you, first peripheral you are going to study, that is timers, 8051 timers and its programming in C. So basically there are two timers, timer 0 and timer 1 in 8051, generic 8051 microcontroller, and we are going to program it in C, probably in mode 1, mode 2, because mode 0 is very basic 13-bit mode. So we can directly shift to mode 1, mode 2 programming. Okay, under that you are going to program these timers to generate time delay. Okay, first, then you are going to use these timers to generate square wave of a particular duration, that is time period, and of a particular duty cycle at a particular pin of uh, 8051, that is IO pin. Then we are also going to program these timers to use these timers as counter, that is to count events that are happening outside 8051. So this is first part of the chapter, that is 8051 timers programming. Second part is serial port programming. Under this first we will see basics of serial communication, then how to connect 8051 to RS232, that is serial port standard. Okay, that is used to interface serial port of 8051 and serial port of computer system. And then actually we are going to uh, program this serial port from C, okay, to transmit and receive data serially. Okay, so these are contents that is same written here. Okay, so in part 1 we are going to study timer programming of 8051 in mode 1 and mode 2. Okay, so there are three parts: generation of time delay using timer, square wave generation, and timer use of timer as counter. Okay, so we will start with lecture 1 uh, from this part 1 of chapter number 2, that is timers programming. So before going to actual programming part, let us have introduction to 8051 timers, and then we will briefly see what is timers mode 1. So as I told you, in 8051 there are two timers, timer 0 and timer 1. Okay, so if you are not aware with what timer is, you can compare these timers with that is a timer available in your mobile phone. Okay, so in the timer that is there in your mobile phone, you can start that timer and it will start counting, starting with 0, and after every second that will get incremented by 1. Okay, so that is the timer in mobile. Similarly here also you can start timer and timer will start counting up. Okay, so only difference is in this, when you use 8051 timers, you can start counting from initial values set by you. That is the only difference. Okay, and whenever you want to stop, in mobile phone, you can stop that timer. Then that timer will stop. Similarly, here also you can stop timer. Okay, so that is the simply one example. Okay, of analogous timer. Okay, so that is available in 8051 timer. Okay, so what is the application of timers available in 8051 microcontroller? That is the main thing. So there are only two applications we can use timers for. First is to generate time delay of precise time duration. Okay, that is first application of timers. And second application is we can use these timers, that is timer 0 and timer 1 of 8051 microcontroller, to count events that are happening outside microcontroller. Okay, so one simple example is, for example, in application in which you are going to count the number of persons entering in a particular room. In that case, you will install a hardware on the door. Okay, and whenever any person enters in the room through that door, then it will generate a pulse. Okay, so that hardware will generate a pulse. So that pulse we can input to 8051 microcontroller, and we can employ any timer, that is timer 0 or timer 1 of 8051 microcontroller, to count that pulse. Okay, so that is called as event that is happening outside microcontroller. So these pulses represents events that are happening outside microcontroller, and we can employ timers of 8051 to count these events, means to count these pulses. Okay, so in that case, that timer we are using as a counter. Okay, so this is the second application of 8051 timers. So generic 8051 microcontroller has two timers, timer 0 and timer 1. Generic is basic. Okay, so under MCS 51, that is a family of 8051 microcontrollers. There are so many microcontrollers. Okay, so that basic microcontroller, that is a generic 8051 microcontroller, has two timers, timer 0 and timer 1. So both of these timer 0 and timer 1 are 16-bit timers. That is count, it will count. Okay, so that is 16 bits, starting with all bits zeros, all the 16 bits 0. Okay, we can say, and it can go up to maximum value, that is all bits 1. Okay, all the 16 bits 1. So that is the meaning. So to hold this count, okay, while counting, this timer 0 and timer 1 has 16-bit timer register. Okay, TL0 and TH0 for timer 0, and TL1 and TH1 for timer 1. Okay, so TL0 and TH0, both two registers, these are 8-bit registers, so total 16-bit. TL0, TH0 16-bit, and TL1, TH1 16-bit timer registers. To control the operation and to configure these timers in different modes, okay, there are two SFR, special function registers, available inside 8051, and these are T mod. Okay, that is timer mode control register. Okay, and this T mod SFR is used to configure this timer 0 and timer 1 of 8051 microcontroller. And one more, that is TCON, that is timer control register, is used to control the operation of timers. So we are going to study these registers in details. So first, that is T mod SFR, timer mode control SFR. So it is a 8-bit, obviously 8-bit SFR. So here this is the format of this T mod SFR. So lower 4 bits, that is from the bit number D0 to D3. Okay, D0, D1, D2, and D3. So these bits are used to configure timer 0, and upper 4 bits, that is bit number D4 to D4, D5, D6, D7, are used to configure timer 1. Okay, now we will see about timer 0. Now see here, these bits are same. Okay, timer 0 bits and timer 1 bits are same. For example, timer 0, M0, M1, C oblique T and gate. Okay, same bits are there for timer. Okay, so now we will see what these bits are. So to configure timer 0, these 4 bits are there, M0 and M1 bits. Okay, so by using this M0 and M1 bits, we can select a particular mode of timer 0. Okay, by using this next bit C oblique T, we can configure timer 0 either in a timer mode or counter mode. Okay, when we use timer mode, that means we are going to generate time delay, and if we use counter mode, that means we are going to count events that are happening outside 8051, which are being inputted as pulses, okay, on a particular pin that is allotted to timer 0. Okay, and get bit is used um, to control the operation of this timer 0 from outside 805. How we are going to study. Now let us start with these modes, that is mode bits M0, M1. So here this table illustrates different modes of timer 0 or timer 1. So M0, M1, if these bits are 0, 0, that means mode 0. If these bits are 0, 1 means mode 1, 1, 0 means mode 2, and 1, 1 means mode 3. So what is mode 0? Mode 0 is 13-bit mode. Okay, so out of 16 bit, only 13 bits are used. Okay, um, that means um, 8 bit. Okay, 8 bit from THX, okay, and 5 bits from TLX. Okay, 8 plus 5, that is 13 bits are used. Means these count in a timer register THX and TLX. Okay, so that may go up to maximum value, that is um, all bits 1 in these 13 bits, that is 8 bits from THX and 5 bits from TLX. Okay, that is the meaning. So this mode 0 is very seldomly used. Mode 1 is 16-bit timer mode, which is normally used. So all the bits from THX and TLX are used, okay, to hold count. That is a 16-bit timer mode. Then mode 2. So we are going to discuss all these modes in detail. Mode 2, mode 1, mode 2, mode 3. So mode 2 is 8-bit auto reload mode, in which case uh, that is only value in TLX, that is lower timer register. Okay, so that will increment from minimum value 00H to maximum FFH. Okay, and initial count to be loaded. Okay, so that is actually loaded in THX. So we are going to study this mode 2 in details. Okay, and mode 3 is split timer mode that we will also study. Okay, so there are 4 modes: mode 0, mode 1, mode 2, mode 3. Mode 0 is 13-bit timer mode, mode 1 is 16-bit timer mode, mode 2 is 8-bit auto reload mode, and mode 3 is split timer mode. Okay, now these M0, M1 decides mode. C oblique T. Okay, so this will decide um, that is a timer mode or counter mode. Okay, so if this bit is 0, that means timer mode. If this bit is 1, means counter mode. We are configuring timer 0 as uh, timer mode if this bit is 0, and if this bit is 1, means we are configuring timer 0 as counter. Okay, so gate bit. So here the explanation is given for gate bit. Gating, that is gating control. This bit is called as gating control bit, and when it is set, then a timer or counter is enabled only when INTX pin is high and TRX control pin is set. Okay, means this gate bit means gating control bit. By using this bit, we can control the operation of this timer 0. Okay, from outside 8051. Okay, so operation of timer 0 means start of timer, that is turning on timer or turning off timer, etc. Okay, so that can be controlled externally. Okay, if this bit is 1, if this bit is 0 means that is to be controlled internally, that is the meaning. Okay, now same bits are there for timer 1 and same functions are there, means we can configure timer 0 and timer 1 in one of these modes. Both timers are having getting control, both timers are having c oblique t bit. Okay, to configure this timer 0 and timer 1 either in counter mode or timer mode. Okay, so this is about T-mod SFR. Now, let us move towards mode 1 of either in timer 0 or timer 1 of 8051. So mode 1, as I told you, this is 16-bit mode. Okay. Now this is block diagram of timer 0 or timer 1 in mode 1. Okay. So this is crystal oscillator. That is a crystal we are going to connect in between OSC1 and OSC2 pins of 8051. Okay, of a particular frequency. So internally that crystal frequency will be divided by 12 if c oblique t bit is 0, means we are configuring timer 0 or timer 1 in timer mode. Okay, that is to generate time delay. Okay, in that case this crystal oscillator will get divided by 12, that is if frequency of crystal oscillator is FOSC, then it will get divided by 12, and that frequency that is a FOSC. So here frequency will be FOSC divided by 12, that is frequency of these pulses will be FOSC divided by 12. So these pulses, okay, actually will be used as timer clock frequency. Okay, so these are being applied at one of the input of this AND gate. This is AND gate. Okay, and other input of this AND gate is TR bit. Okay, so TR bit means either it is a TR0 or TR1. Okay, so TR0 is timer 0 for timer 0 and TR1 is timer 1, and these bits are there in second control register of timer 0 or timer 1. So that is a TCON, timer uh, control register, TCON. Okay, so this is TR0, sorry. So this is TR0 bit and this is TR1 bit. Okay, so TR0 and TR1 bits are used to turn on or off timer 0 or timer 1. Okay, so here, so when this bit is 0, okay, when this bit is 0, these clock pulses will stop reaching at the output of this AND gate. Okay, now what is this? These are timer registers. Okay, either TH0, TL0 or TH1 or TL1. So this is in case of timer 0 and this is in case of timer 1. Okay, so this block diagram applies to both timer 0 and timer 1. Okay, now this FOSC divided by 12 frequency clock pulses will be used by timer 0 or timer 1. Okay, so if this TR0 or TR1, in case of timer 0 this bit will be TR0, in case of timer 1 this bit will be TR1. If this bit is 0, means these pulses will not um, reaching at the output of this AND gate, and it will not, okay, since it is not being outputted at the output of this AND gate, it is not reaching this timer register, and count in this timer register will not be affected. Whatever initial count, that will remain same. For example, here suppose initial count is 0 0 and here also it is 0 0. When this TR bit is 0, these clock pulses will not reach at the output and there is no effect on in the count of this timer register. Okay, now assume that this bit is now we have made it 1. Okay, this bit is now 1. Now since this bit becomes 1, what will happen? These pulses, okay, see this is simply this is AND gate. Okay, so this is AND gate. So when this bit becomes 1, TR bit becomes 1, these pulses starts reaching at the output. Okay, so this pulses we are getting at the output of this AND gate, and these for each, due to each pulse, okay, count in TH and TL register will start incrementing. Okay, suppose initial value is 0 0 0 0, so due to one pulse it will get increment by 1, it will become 0 0 0 1. Due to next pulse it will again get incremented by 1, that is 0 2 0 0 0. In this way count in TH and TL register starts incrementing due to pulses it is getting. Okay, so in this way, okay, but when this will happen, when you make this TR bit, okay, 1, okay, then count in TH and TL register will starts incrementing from initial value you have loaded in TH and TL. Right now we are assuming that TH and TL registers are loaded with initial value 0 0 0 0. Okay, now when it is start incrementing, it can go up to maximum. Now this count we are writing in hex. Okay, so it can go up to maximum value in this timer register, that is F F F F. Okay, so it can go up to maximum value F F F F, and after that due to one more pulse what will happen, count in this timer register again rollovers to 0, all ones to all 0. Okay, that is F F F F maximum value to minimum value 0 0 0 0. Okay, because if you add 1 into this count F F F F, what value it becomes? It becomes 0 0 0 0. This is called as rollover of count. This is called as roll over of count in timer registers. Okay, so that is when such rollover of count happens, what will happen? There is a one bit, okay, that is timer TF bit, timer flag bit, or overflow flag bit. Okay, so that bit is in a TCON SFR we are going to study. So this TR bit and this TF bit, okay, that is TR0 TR1 and TF0 TF1 bit. Okay, so these bits are there in TCON SFR. Okay, so in case of timer 0, if count rollovers in TH 0 and TL 0, okay, count in TH 0 and TL 0, okay, rollovers from all ones to all zeros, that is F F F F to 0 0 0 0, what will happen? TF0 flag bit will get set. Okay, so that is we are call it as a reset of timer 0. Okay, so in this way this timer 0, timer 1, mode 1, okay, operates. Now we will see where are these TR0 and this TR0 and TR1 and TF0 and TF1 control bits. Okay, so these are in this TCON. Okay, so this is a timer control register. So this is TR1 and this is TR0. Okay, TR0 is used to turn on or off timer 0. TR1 is used to turn on or off timer 1. Okay, for example, if you want to turn on timer 0, so you have to make this bit as 1. If you turn off timer 0, you have to make this bit as 0. Okay, so turning, that is the start of timer. We can start timer by making this bit 1, and we can stop timer by making this bit 0. Okay, similarly this TR1 bit is used in case of timer 1. To turn on timer 1, we can make this bit 1. To turn off, we can make bit this bit 0. Okay, uh, Now we discussed in previous slide, we discussed about TF0, okay, timer flag 0, and TF1. Okay, so whenever there is a roller of count in case of timer 0, this flag bit will get set. Okay, roller means whatever count is there. Okay, whatever count is there in timer register, that is TL0 and TH0 in case of timer 0, if it rollovers, okay, means changes from all ones, that means all ones means FFFF to all zeros means 0000, then in that case this TF0 bit will get set. Okay, and in case of timer 1, okay, in case of timer 1, this timer register will be TH1 and TL1. Okay, so if count in TH1 and TL1 due to these pulses, okay, reaching at the input of this timer register, which are incrementing count in this timer register, due to that, if count in TH1 and TL1 rollovers from all ones to all zeros, means all FFFF to 0000, in that case this TF1 bit will get set. That is the meaning. Okay, so in this way this mode 1 of timer 0 or timer 1 operates. Okay, so when we are going to use mode 1, what we have to do, according to what time delay, okay, we want, we have to first load initial count in this timer register, either TH0 TL0 or TH1 TL1 with some initial value. Okay, and when you turn on either timer 0 or timer 1, okay, by making TR0 or TR1 bit 1, okay, these pulses will start reaching to this timer register, and due to each pulse, count in this timer register will get incremented by 1. Okay, in this way count in this timer register can go up to maximum value all ones in this 16 bit. Okay, and if this 16 bit is represented in hex, so that maximum value will be FFFF, and after that due to one more pulse, okay, what will happen, count in this timer register rollovers from all ones to all zeros, means FFFF to 000, and in that case this uh, timer get flag bit get set, and this timer flag bits and this timer run bits are in TCON SFR, that is timer control register, that is upper 4 bits, okay, are used for timer 0 timer 1 from this TCON. Okay, so this is about that is mode 1 of timer 0. Okay, so we started with introduction to timers. So we saw applications of timers, then timer 0 and timer 1 are there. So there are three registers related with timer 0 and timer 1, that is timer registers, that is TL0 TH0 in case of timer 0, TL1 TH1 in case of timer 1. Then T mod is there, that is to configure these timers. One SFR 8-bit SFR there is there, that is T mod, and to control the operation of this timer 0 and timer 0, there is a TCON register. Okay, so this is a T mod register or SFR, and this is mode 1, and this is TCON SFR. Okay, so I think this much is sufficient. So if any doubt, we can discuss in live session. Okay, I will stop here.